Okay, so guys, now we move on. Now we just completed method number one, where we were converting a decimal number, okay, into binary format. Okay, and we were using something known as method number one, or we were using the subtraction method. Now I'll be showing you how to convert a decimal number into binary format using method number two, where we do a lot of division. Okay, so let us take the same number 40 again. Okay, the number 40, we're taking it again. Okay, so basically what we do is we take the number 40 from over here. Okay, so we write number 40, for example. And what we do is we divide it by 2. Okay, you take the number 40 and you divide it by 2. So in 40, how many 2's do we have? We have 20 2's. Okay, so we put 20. And then it's very important that you should also mention how much the remainder is. Okay, so if there is no remainder, now in this case, there is no remainder. 40 divided by 2 is 20 and there is no remainder. But you must mention over here 0, which means there is no remainder. Okay, let's go again one more step. And if you were to divide 20 by 2, okay, 20 divided by 2, how many 2's do we have? You would get 10, remainder is 0. There is no remainder. Okay, then let's take 10 divided by 2. How much will we have? We have 5 2's in 10. Again, remainder is 0. Okay, now let's redivide 5 by 2. Let's divide 5 by 2 and you would tell, yes, there are 2 2's in 5. 5 divided by 2 is 2. There are 2 2's and yes, there is one remainder as well because 2 times 2 is 4. Okay, we need 5. So there is one remainder. Okay, right. Let's keep dividing. Let's keep dividing. 2 divided by 2 is 1. Okay, in 2, how many 2's are there? There is 1. Is there any remainder? No, there isn't any remainder. So over here we say 0. Okay, over here we say 0. Now we have to start writing our answer. Okay, now we did the working. Now we start writing our answer. So how do we write our answer? We start from, I forgot to mention one more thing. There is nothing, you cannot divide anymore. You have come to the bottom point. Okay, you cannot divide anymore. Okay, so you have come to 1. Once you reach 1, that's it. You cannot divide any further. Okay, right. Okay, so how do we write our answer? We start from this side. We start this way and then we go upwards. Okay, so this is how we write our answer. We start with 1, then we write 0, then we write 1, then we write 0 0 0. Okay, so let me show you how I would write my answer. I would write it like this. Start from here, 1 0. Now we start moving upwards, 1 0 0 0. Do not forget to put base 2. Okay, let's take another example. Okay, let's take another example. And a quick thing, guys, if you look at the last point, if you look at this last point, normally we write binary numbers in 8 bits. Okay, we write them in 8 bits, or we write them in 16 bits, or we write them in 32 bits, or we write them in 64 bits. So right now, if you look over here, how many bits do we have? We have 1, we have 2, we have 3, we have 4, we have 5, we have 6. So you can add another 2 zeros in front to make it 8 bits. Okay, so you can add 2 more zeros in front and make this an 8-bit answer. Okay, this is optional, not compulsory. But normally your computer would display binary numbers either in 8 bits or 16 bits or 32 bits. Okay, so that's why we try to, make it at least 8 bits by adding 2 zeros in front. Okay, right. Let's take an example. Let's take the number 67. Okay, let's take the number 67 from over here. So let's come to our notepad. If we were to take the number 67 over here, so we have a decimal number 67 and I want to convert this into binary format. Okay, we are using method number 2. Okay, so we write 67 over here. 67 is written over here and we divide it by 2. Now, if 67 is looking like a big number to you and you're finding it difficult to divide by 2, take the single digit. Start with 6. In 6, how many 2's do you have? You have 3. Okay, so in 6, you have 3. Write 3 below 6. Is there any remainder? There is no remainder. So now ask, in 7, how many 2's do you have? Yes, you have 3. Okay, and then there is a 1 remainder. Okay, I'll give you a quick tip. If the number you're dividing, okay, the number you're dividing, if it is an odd number, there will always be a remainder. If the number you're dividing is an even number, there will not be a remainder. Just keep that in mind. Okay, right, moving on. Now we're going to divide 33 by 2. Okay, so if 33 is a big number for you, take 3. Okay, so in 3, how many 2's do we have? We have only 1. Okay, and remember there is a 1 remainder as well. Okay, so we put that 1 remainder over here. Okay, so that becomes 13 now. Okay, so you have to ask yourself, in 13, how many 2's do we have? We have 6. Okay, 6 times 2 is 12. Okay, we need 13, so there is a 1 remainder. Okay, so guys, like I told you earlier, look, this was an odd number, so automatically there is going to be a remainder over here. Okay, now look, this is an even number, so in the next step there will be no remainder. Okay, let me show you. Okay, so if you come over here and if you divide 16 divided by 2, okay, so yes, the answer is 8 and there is no remainder. Okay, so do you see, since this was an even number, in the next step there wouldn't be a remainder. Okay, right, let's go on. Until we get 1, we have to keep going on. Okay, so in 8, how many 2's do we have? We have 4. Okay, there is no remainder. Okay, so we put 0. Let's keep going. Okay, in 4, how many 2's do we have? We have 2. There is no remainder. Let's keep going on. In 2, how many 2's do we have? We have 1 and there is no remainder. Okay, and like I told you guys, your answers, you will go from this way, okay, this way, and then you move upwards. Okay, go this way and then you go upwards. So your answer, the final answer would be 1 0, then 00, sorry, 000, 11, 000, and then you have 11. Okay, yeah. Okay, so once again, if you check how many digits do we have? 1 2 3 4 5 6 7. So we have 7 digits. It would be great if you can make it 8 digits, so just add a 0 in front. Okay, 0 doesn't make a difference. It just makes it 8 digits because that's how your computer normally would display a binary number. It would display in groups of 8 bits. Okay, right, let's do another example as well, and thereafter I hope you will be attempting some on your own as well. Okay, let's take another example. Let's go back to our tute. Okay, so over here, let's take a number such as 4095. It's going to be a very long number, so let me take 255 because 4095 will take quite some time. Okay, let's take 255. Okay, so if I was to take the number 255, let me write it over here. Let's write 255 over here. Okay, and I keep forgetting we have to put the base as well. Okay, so if we were to take 255, let's start dividing. We're using method number 2. We're using method number 2. So let's write 255 and we are going to divide it by 2. Okay, so 255 is a big number. Let's take single digits. Let's start with 2. So in 2, how many 2's do we have? We have 1. In 5, how many do we have? We have 2. And there is a 1 remainder. So I put that 1 over here. So now the number becomes 15. In 15, how many 2's do we have? We have 7. Okay, and remember 7 times 2 is 14, but we are dividing 15, so there is a 1 remainder. Okay, there is a 1 remainder. And let me also remind you, look over here, we have a odd number, so definitely the next step will be having a remainder. If this was an even number, then there wouldn't be a remainder here, it would be 0. But since this is an odd number, there will always be a remainder. Okay, right, let's continue. So now itself, you should be able to say the number is 127. So in our next step, there is going to be a remainder because 127 is an odd number. Okay, right. Let's take, we cannot take 1. Let's take 12. In 12, how many 2's do we have? We have 6. Okay, we have 6. There is no remainder. In 7, how many 2's do we have? Okay, in 7, we have 3 2's. Okay, and we have a 1 remainder. Okay, right. Let's keep going. Okay, so 63, let's take 6. In 6, how many 2's do we have? We have 3. In 3, how many 2's do we have? We have only 1. And we have a 1 remainder. Okay, let's take 31. In 30, if in 3, how many 2's do we have? We have only 1. And there is 1 remainder that comes over here. So this becomes 11. In 11, how many 2's do we have? We have 5. Okay, and then we have 1 remainder as well. Okay, let's go on. In 15, how many 2's do we have? We have 7. And there is 1 remainder because 7 times 2 is 14. There is 1 remainder. Let's keep going. In 7, how many 2's do we have? We have 3. And there is 1 remainder. Okay, let's keep going. In 3, how many 2's do we have? We have only 1. And there is 1 remainder as well. Okay, so how do we write our answer? We go this way. Okay, and then we go upwards. Okay, so our answer is going to be 11 11 11 11. Okay, so let's get it down. 11 11 11 2 4 6 8. Okay, So in this case, guys, we do not need to add any extra zeros because we have 8 digits over here. 2, 3, 4, 5, 6, 7, 8. We have 8 digits over here. So we do not need to add any more zeros in front of it to make it 8 bits. There are already 8 bits over there. Okay. So I hope it makes sense on how, I mean, it's up to you to decide now. When you get a question of converting a decimal number into binary, you can now decide, shall I go with method 1 or shall I go with method 2? Method 1 involves subtracting. Okay. Method 2 involves dividing. Okay. Now, if you ask me personally, which method I prefer using the subtraction method. Okay. That's much shorter. Okay. And you can do it mentally as well. If you do the division method, you have to write it and go step by step, you have to go. I feel the division method is a little more time consuming and takes up a lot more paper space. But the subtraction method number 1, can be done much faster. You can even do it mentally. If you can just picture the position values, you can start putting them in place. Okay. But remember, guys, this comes with practice. As you keep practicing it, it becomes easier and you become faster at it. Okay. So now we have finished a major part. Okay. We have finished a major part, which is how to convert a decimal number into binary. And we also spoke how to convert a binary number into decimal. Okay. So before we go any further, before we talk about now in our tutor, the next part is talking about hexadecimal numbers. This is the third number system. Okay, so before we get into hexadecimal numbers, let's do a few past paper questions. Okay, so that we know what the past paper expects from us in this part of converting binary numbers into decimal and decimal numbers into binary. So we'll do a few past paper questions next. Okay, guys.